Hello, everyone. My name is rreca. I'm a developer relations engineer at Google, working on Compose, and today we're going to talk about testing Compose. So in case you don't know yet, Compose is a new UI toolkit made for Android and developed by the Android team. And I don't usually get excited with new APIs or libraries, but this time is definitely different. See, I've always avoided the UI side of things in Android. Android has evolved a lot, and if you've been focusing on something else, it was hard to keep up with everything that's happening. So Compose is, of course, yet another thing to learn. However, it's opinionated, it's Kotlin, it's modern, and even I can use it. Using Compose is actually a lot of fun. Also, it's created by an amazing team, and it's tested. More than 2/3 of lines of code in Compose are inside tests. This makes Compose itself pretty solid, but what's interesting for us is that Compose was created with testing in mind. So app developers will immediately benefit from this, since the same APIs used in the development of the toolkit are available for us. So first of all, a disclaimer, Compose is in alpha right now. This means that the APIs are starting to get their final shape, but some parts are a little bit behind. And since testing has impact on so many parts of the toolkit, the APIs that we're going to see today have a big chance of getting tweaks until beta and stable. So always check the documentation for the most up-to-date information. Otherwise, what I'm going to show here today is probably already a lie. So the first thing we need to talk about is semantics. Testing relies heavily on something called the semantics tree. In Compose, there are two trees to take into account that your composables will emit. The UI tree, that is emitted by each composable that emits UI, which is used to render pixels on screen. And then the semantics tree that is created by only some composables. This semantics tree is used by accessibility services like TalkBack, for example, to provide descriptions of what's on screen, the labels, what areas are clickable, etc. And it's also used in tests to verify the behavior of our UIs. So let's look at an example. This is a composable button that takes a slot for a text and a slot for an icon. An accessibility service like TalkBack is going to announce like, because the toolkit's text composable emits its value by default to the semantics tree. This means that supporting accessibility in your app is not going to be too hard because Compose comes with good defaults. However, you might want to override this default behavior. Maybe you want to also announce the icon, or you want this whole button to be announced and not its children. For that, you can use the semantics modifier. This lets you set semantics properties like the accessibility label and override the default behavior. In a test, when looking for this button, we would just have to look for this new accessibility label. Now let's look at a real example that we will reuse later. In JetChat, one of our official samples, the accessibility reviewer requested that these two texts be merged into just one announcement, so that accessibility services like TalkBack would say Ocean Clark 3:48 p.m. instead of making two different announcements. The way you do this is by adding the semantics modifier to the parent composable, a row in this case, and setting the merge all descendants parameter to true. Each semantics property has a different merge policy, which in the case of the accessibility label is a simple string concatenation with commas. So the single announcement would be Ocean Clark, 3:48 p.m. But let's stop here because the semantics part is going through changes as we speak, and this might be obsolete very soon. But this is enough to get us starting on testing. So let's look at a Compose test example finally. Compose tests are very similar to any other UI tests. You have a rule that starts an activity, and you communicate with it through APIs that talk to the instrumentation. With Compose, you get a Compose test rule that can be obtained with either create Android Compose rule, passing an activity, or with create compose rule that does not. The rule of thumb is always try to use compose test rule. Check the documentation, by the way, if you want to use create compose rule, because there's an extra step that you have to take, basically add the component activity to the manifest. In the test, or before the test, we can use the compose test rule to set the content if you're not setting an activity already. This takes any composable, and this is very important, and we'll talk about that later. But because compose recommends unidirectional data flow, you normally control exactly the inputs you need to execute your test. In this case, the main screen takes a UI state, so we pass fake data that we control. It also needs a material theme, so we provide it. By the way, all compose tests are instrumented for now. This means that they need a device to run on. We're exploring the possibility of host site tests, but the priority right now is to get the APIs right. The finders, matches, actions, and assertions are similar to expressors, but in my opinion, they're a bit more discoverable. So let's look at them closely. There are two types of finders, the ones that find a single node and finders that find collections. For single node finders, you can pass a matcher to onNode, or you can take a shortcut like onNode with label, onNode with substring, tag, text. Same thing for collections. You can call onAllNodes with a matcher or use one of the shortcuts. Finally, onRoot will return the root node, obviously. Before continuing, it's important to note that all finders take a parameter called useUnmergedTree. It's used to treat all nodes as unmerged, so that in our example before, we're able to match only the author name or only the timestamp, even if we've overridden the default behavior. So moving on to matchers, there are three types, or two and a half. Semantics, hierarchical, and selectors is a different API. Semantics matchers, they're called like this because they match against properties in the semantics tree. They're very diverse. You have things like has label, has text, has test tag, etc. I'm going to give you a couple of seconds to go through the list so that you know what's available. Hierarchical matchers let you go up, down, and sideways on the semantics tree with matchers like has parent, has any child, sibling, etc. Selectors is a different category, and it's a nice way to make your test a little bit more readable. Again, you can pass any matcher to or combination of matchers to the filter function, or use any of the hierarchical selectors. With them, you can write tests like this one on the right. You need to start with a finder. So on a node that has a player tag, and then we start using selectors on its children, filter the ones that have a click action, make sure they're 4, get the first one, and verify its name. So moving on to assertions, again, you can use the generic assert function, passing any matchers from before, or you can use any of the shortcuts. Assert is displayed, selected, label equals, etc. There are some assertions related to size and position, and then we have the assertions for collections of nodes. Assert all, assert any, and assert count equals. Finally, actions and gestures. These actions let you click, inject gestures, and key presses. Or you can create your own gestures where you can get really, really precise in both position and time. All right, so now that we've looked at most of the API, let's look at some interesting patterns that show up with these APIs. The first one is my favorite and is about how trivial it is to test in isolation. This is the rally sample, and in it we have this hero animation that shows your accounts and your bills in an animated donut chart. There's a lot of trigonometry and more math to get the animation right. And sure, you can unit test this, but ideally this is something that you want to analyze frame by frame. So for that, we created a simple screenshot testing framework that is available in the sample code. The important bit about this is that we don't want to test the whole app or the whole screen, as it would make the test slower and it would make the device compare too many pixels. We don't want to make the test navigate to the charts and then take a screenshot of the whole device. Instead, we're only interested in the animated circle composable, so using the compose test rule, we can bypass the rest of the app and just set the content to it. The parameters tell us exactly what data we need, so we just pass a bunch of proportions, a list of colors, and a modifier to give it some size. And this is what our test suite looks like. It's not pretty, but it's using an appropriate amount of pixels and it's super fast. Now, how did we write these tests? Well, we used something called the clock test rule. Again, something super interesting and new. This rule lets us control time in animations deterministically, which is amazing if you're used to doing anything similar in the view world. The compose test rule exposes the clock test rule, and it has methods like pause clock, advance clock, etc. This way, we can start the test with a paused animation clock before we set the content. Then we show the animated circle, and this is what the test would see at this point, a very small arc at the top. After that, we can advance the clock by a specific time in milliseconds. In this screenshot, we've advanced by 600 milliseconds. And this shows the animation in a transitional state. It's important to note that this operation is immediate. It doesn't take 600 milliseconds to execute. Finally, we call our own function to take a screenshot and assert that the screenshot matches the golden image that we said before. This is part of the sample. This is not a framework API. This function calls the capture to bitmap test API, which is part of the toolkit, that you can call with any composable. This is also synchronized, which is also very important. The absolutely amazing thing about this is that this test is never flaky. It always produces the same screenshot, even in the middle of an animation. All right, the next interesting pattern is something that has always been possible, but now it's easy. Simulating changes from tests. This is a setup method for the JetChat sample that starts one of the screens. There's a lot going on, but the interesting part is that we have a property called theme is dark, which is a mutable state flow. It starts being false. And since compose has tools to convert a flow to a composed state, that's what we do in this test. We pass it to our theme, we collect it as state, and we pass it as a Boolean value. Now, because the theme is reading a state, we can trigger a recomposition simply by mutating it anywhere in the test. For example, in this test, we swipe the messages log to show the jump to bottom button, which is that one. The scroll position should be remembered across recomposition. So that's exactly what we're testing here. We can assert that first the button is displayed, then change the value of the property to switch everything to a dark theme, and then assert again that it's still there. That means that the scroll wasn't reset. We're not testing that the theme has the correct colors or anything like that. We're just testing that the state is correctly persisted. And as you can see, we didn't need to add any synchronization calls. When we mutate the value, a recomposition is triggered. And recomposition is already synchronized with tests, so you don't have to worry about it. Can you imagine what it would take to do this in the view world, changing the theme to dark in the middle of a test? All right. So finally, what happens when you have a hybrid screen in which you have Android views and composables at the same time? Let's say we want to test this screen from the Crane sample app. It has a map view inside a composable screen. So we create the compose test rule normally. and we set the content to the detail screen, which has this map view embedded inside. Now we complete the test with finders and assertions. So as you can see, we can mix and match statements from the Compose test APIs with Espresso's APIs, depending on the target. There's nothing you need to do to switch from one to the other or to synchronize between them. So that's it. If you want to keep up to date with the latest APIs, we're going to be updating the testing section of the official docs regularly. And we're trying to release samples with every alpha release. So check those out if you need to copy past tests. As always, we're listening to your feedback, and you can send it via filing issues or chatting with us on Slack. I'm also on Twitter. And yeah, thank you for your time. I believe we have some time for Q&A. All right, we have a couple of questions. What's the plan? Asking for dates is not going to go well. What's the planned date for stable release of Compose? Right, I'm going to pass on this one because obviously no one knows, and we are not in the position to set a date right now. I think what we said is that we are going to have a beta next year, and we'll see about stable. So next question. How to Compose deal with espresso flakiness? That's an interesting question because it's assuming that Compose is still using espresso, and they're completely right. We are actually relying on espresso right now, especially for the synchronization part. But we don't know how that is going to be in the future. So to answer the question, Compose is not going to depend on espresso for synchronization. And flakiness is normally a product of bad synchronization. So what the team is working on is making sure that you don't have to wait for anything, that everything is synchronized. We've covered this a couple of times in this presentation. So when you trigger a recomposition, everything is synchronized. So your test is not going to continue until the app is in an idle state. And there are some edge cases that we still need to work on, but in my opinion, Compose is going to be much less flaky than Vue. Not espresso. Espresso is probably not the problem here. It's just that the Vue system is really complicated, and it was designed a long time ago. Okay, next question. Is it preferred to use mutable state flow over mutable live data? 100% the same thing for our example in the theme section. You can perfectly use mutable live data. I just like to use flow because I think it's the future. We're going to see a lot of it, and I'm basically, every time I can use it, I will use it just to get some practice, basically. Okay, the next one. Okay, we have 30 seconds, so I think I can take another one. It's the first one. How would one write something like an end-to-end test or a component test with a Compose test framework? Okay, they're completely different things, and I think this goes very well with the difference between create Android Compose rule and create Compose rule. If you are doing an end-to-end test, you can start an activity that has a Compose screen, and you will execute all the lifecycle methods in the activity and do all the things that you need to do. If you want to do a test for a specific component, for example, a checkbox or the animation that we saw before, then you isolate as much as possible, you use compose test rule, and you make the test as small and isolated as possible. And I haven't seen the 1 minute left thing, but I don't see new questions. So yeah, feel free to reach me on the talk platform or on Twitter if you have any questions. We're also on Slack, and as I said before, you can send us feedback. We are really looking forward to seeing where this gets us. All right, thank you very much.